So today we're going to be looking at the multiplication of coded data. So previously we looked at what would happen to variation if we had the coded data and we were doing addition or subtraction to the coded data, and we discovered that that has it doesn't change the variation, the standard deviation of our data set. Now let's consider what happens if we multiplication does to variance and standard deviation. So we're going to consider the cost of hiring a taxi. For which a customer pays a fixed charge of $3 plus $4 per kilometre. So we're going to say that Y is the total cost, X is the distance travelled, and therefore the equation would be Y equals 4X, because we take the $4 per kilometre and there's a fixed charge for a journey of $3. So let's consider some values. So if the distance, and we're going to just look at the raw data to get a feel for what's going on, and then we've got the cost, which is in dollars, and that's our Y, and this is our X. So if they go 1 kilometre, it's going to be $7. If you do two kilometres, that's going to be 8 plus 3, which is 11. If you do 3 kilometres, that's going to be 12 plus 3, which is going to be 15. So what does this show us? As the distance goes up plus 1, the cost goes up plus 4. 7 plus 4 is 11. 11 plus 4 is 15. So when the distance, as distance varies by plus 1, the cost varies by plus 4. The variation in cost is affected by the multiplication times 4, but not by the addition. So let's just look at the data to see this. So as you increase the distance each time by 1, you see the multiplication factor 4 being added each time, which you get here, but you don't see this plus $3 standard fixed charge. That doesn't reflect. You don't see 3 coming into the data set. Now, if we consider the graph of y equals 4x plus 3, then the gradient of the line is what affects the variation of y. If we increase the x coordinate of a point on the line as y coordinate increases by 4. So let's look at the data set x, 1, 2, 3, and then we're multiplying that by 4, and it stretches it. So the whole data set then goes to 4, 8, 12. This affects the pattern of the spread. What happens when we add the plus 3? So we get our 4, 8, 12. That's then going to go to y equals 7, 11, 15. Oops. There's no effect on the spread. So the adding of the 3 doesn't affect the spread. That's what we looked at previously when we were doing our coded data sets when we were adding, and we saw previously that there was no effect on spread when you add or subtract. But when you see the original data set 1, 2, 3, and then we have multiplied it by the 4, we've stretched it 4, 8, 12. You can see by looking at the two sets of data that the spread is going to be different with these two sets of data. And you can see when you look at the 4, 8, 12, then added 1, 7, 11, 15, there's no change in the spread. We can, let's draw a timeline of the journey, of the different costs of journeys. Let's do a number line here. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'll just stop there. And now we've got our distance, which is x. So our distance that we were looking at, we looked at 1 kilometre, 2 kilometres, and we looked at 3 kilometres. And now we look at the cost. So for our 1 kilometre journey, the cost was $7. For our 2 kilometre journey, the cost was $11. So that cost was 11. And for our 3 kilometre journey, the cost was $15. So you can see by looking at, as we've done this number diagram, you can see very easily that the spread is changed by the multiplication factor. So we can see that the range here is 4 times the range of x. So the range here is 2, and the range here is going to be 1, 2, 3, 4, 5, 6, 7, 8. 2 times 8, 2 times 4 is 8. So if we were to think, what this tells us that the standard deviation of x will be a quarter of the standard deviation of, of our coded data set, and our coded data set is the 4x plus 3. So our coded data sets are 4x plus 3, and the standard deviation of our original data set x is going to be a quarter of that, of the standard deviation, and therefore the variance, and if you think about variance, is the square of the standard deviation. So the variance of x will be a quarter squared, which is 16th, times the variance of the coded data set. We can put this into general terms for, let's put down here a bit more, for ungrouped data. The sum of x squared over n minus the mean squared is going to be 1 over a squared, where we've got the for the coded data set, where we've got the sum of ax minus b squared over n minus square root ax minus b over n squared. So the a, in this case the a is the 4, the multiplication factor. We take that out, and we for the variance is going to be 1 over a squared. And for group data, we'll have the square root of x squared f over the sum of, f minus the mean squared is going to be again 1 over a squared. Then we've got our sum of our coded data squared multiplied by f over the sum of f minus the sum of our coded data f over the sum of f all squared. So let's look at a couple of examples. The standard deviation of the prices of a selection of brand name products is $24. The imitation products, so that's like your brand name products like your Kellogg's cornflakes, etc. And your imitations are like your Tesco's own or your Lidl's own make, kind of copy versions. So the imitations of these products are sold at 25% of the brand price. Find the variance of these imitations. So the variance of the coded data is going to be the 0.25 times x. So x is going to be the brand price. So the imitation price is 0.25x. So we're going to be using that the variance is of ax is equal to a squared times the variance of x. So we've got our, we're wanting the variance of the imitation products. So the variance of 0.25x is going to be Now A is 0.25, and we're going to square that times the variance of x, which we are given is 24. So it's going to be 0.2, oh, we've given the standard deviation, sorry, we're given the standard deviation. So the variance is the standard deviation squared, and that's going to be $36. Let's look at another example. So we're given that the sum of 3x minus 1 squared is equal to what, 9136. The sum of 3x minus 1 equals 53, and we've given that the number of values is equal to 10, and we want to find the sum of x squared. So we know that first we find the mean. We knowing that the mean is the coded values is 1 less than 3 times the mean. That means that 3x minus 1 must equal 3 times the mean minus 1. So we've got 3 times the mean minus 1 equals, and we know what the sum of 3x minus 1 is 53, and we know we've got 10 values, so we can then rearrange this to get the mean as a third times 53 over 10 plus 1, bring that over, which gives us 2.1. Now we know that the variance of x is 1 over a squared times the variance of ax minus b. So the variance of 3x minus 1 must be 9,136 divided by 10 minus 5.3 squared. So the sum of x squared over 10 minus the mean, which was 2.1 squared, must equal a ninth of the variance of the coded data, which we've got here. So that rearranging that, we get 98.39 here, and we'll just, sum of x squared over 10 minus 4.41. Rearranging that gives us the sum of x squared is equal to 1028. So I hope that helps.